Hey guys, what's up? Mr. Mathematician is back, and this time I have a series of circles for you. It is all going to be about circle. This is part 1. Sorry for the delay as I had some technical issues, and as you can see in the diagram. So let's start. Over here, what we need to do is we need to prove that OE, that is a bisector of AB and is perpendicular to it, is smaller than OF, that is bisector of CD and perpendicular to it. We can visually see it, but we need to prove it theoretically. Many times the figures are not drawn to scale. So first of all, AB is greater than CD. It is already given in the question, so we'll note it down in our answer sheets. So we'll write AB is greater than CD. And in the brackets will write given. That means it was already given in the question. Now over here, if we see that we already have the information that AB is greater than CD. Over here we also know that AB and CD are two chords over here, and OE bisects AB and is perpendicular to it. So we'll note it down. We'll write down OE is perpendicular to AB. If you don't know, this is the sign for perpendicular or reverse T. Now we'll do the same for CD. We know that OF over here in the diagram, OF bisects CD, so it is perpendicular to CD and divides CD into half. So OF is perpendicular to CD. Okay, now using these two statements or using these two equations, we'll prove that AE, that is AE, is greater than CF. Why it is greater? Because OE and OF divide AB and CD into half respectively. So half of AB will always be greater than half of CD, as AB is greater than CD, and that was already given in the question. So we'll note it down that AE is greater than CF over here. Now what we are going to do is, over here first we'll mark. Over here I have a diagram, so we'll mark in it. OA and OC would be always equal. Why? Because they are the radii of the circle. That means any point that connects to the center would always be, the distance between them would always be equal. So OA is equal to OC over here, because they are the two line segments, the dotted line segments are a radius. So we'll write it down as OA is equal to OC is equal to radius. Instead of radius, you can also write a small r. Now we have a lot of information. So what we'll do is, first I'll mark it on the diagram to explain you. So now the information we have is AO or OA is equal to OC. So I'll make one line in both the lines. This indicates that OA and OC are equal. Now we know that AE and EB are equal. AE and EB are equal because OE bisects it. So we'll mark it with 2 lines. We'll do the same for CD with 3 lines. OF is the bisector, so it will divide CD into 2 parts. Okay, now we have a lot of information, and over here, if you see, we have AEO. We have AEO, that is a right angle triangle at angle E. It goes the same for CFO. CFO, triangle CFO, angle F is 90 degrees. Okay, so now over here we have two right angle triangles and we'll use Pythagoras theorem and I'll show you how. So over here in a first right angle triangle we have AO or OA, that is our hypotenuse. And so as per Pythagoras theorem, side number 1, the square of side number 1 plus the square of side number 2 is equal to the square of hypotenuse. We'll note it down. Over here our first side is AE, so square of AE plus OE square is equal to OA square. Now over here guys, OA is our hypotenuse. Also it is a radius. OA, as we saw earlier, it is a radius. Now we'll do for second triangle where OC, there is also a radius, is the hypotenuse. So we'll write CF square, that is side number 1, plus side square of side number 2. So square of OF is equal to OC square, that is the square of side number 2. Now over here, wait a second, I'll just zoom in. As you can see, OA and OC were the radius. Both of them are radius and therefore their square would be equal. So square of OA would be equal to square of OC. So we can also write equation 1 equals to equation 2. Therefore we can write that square of AE plus square of OE is equal to CF square plus OF square. Now over here what we'll do is, this is an important step. So using Pythagoras, as OA and OC were our radius, we wrote another statement or another equation. Now in this equation we'll replace CF square with AE square. Now this is an important step. Why is it important? Because to solve these kinds of sum you need to apply logic. So what we'll do is, as we knew that AE was greater than CF, you remember that? AE was greater than CF. So instead of CF, when we write AE, we'll write AE square over here instead of CF square. We'll not mention any sign right now. First we'll complete the equation. So AE square plus OF square. Now as CF was smaller than AE, so when we add AE, we replace CF with AE square. This side, the right hand side, would become greater. Now on both the sides we have AE square, so we'll cancel it out. Now as you can see, we'll write one more statement, that is OE square is smaller than OF square, as the square of OE is smaller than the square of OF. OE would also be smaller than OF. Sorry, this is my fault. This should be smaller than sign, not equals to. Now here we are with our last equation, that is OE is smaller than OF. This is a little tough question, so you need to practice this question, and this question will also develop your logic. If you want to note it down or you want to have a peek at it, pause the video here and have a look. I'll just have a quick recap. We had to prove OE is smaller than OF. Then we found out different equations, as you can see. We also found out that half of AB, chord AB, is greater than half of chord CD or DC. Then we had two radius, that is OA and OC. And with the help of Pythagoras, we found that in both the cases, the radius was hypotenuse. So we had an equation in which we replaced both the sides were equal, and we replaced CF square with AE square. knew that AE square would always be greater than CF square. So right hand side became greater as we replaced it. So when right hand side became greater on both the sides, we get the same, so we cancelled out and we found the answer. Thanks for watching guys, and stay tuned for more updates.